You know, when you get in your car, you're not just getting into a machine anymore. You're stepping inside a powerful, invisible network of computers. They're making thousands of decisions every single second. And believe me, the market for this hidden network is absolutely exploding. Just take a look at this number, $120.9 billion. That's the projection for the value of the automotive electronic control unit market by 2032. It's staggering. And we're not talking about some far-off sci-fi concept car here. Nope, this is the tech that's already inside the car you drive every day. It's managing everything from how your engine performs to whether your power windows go up and down.
And this is a truly global thing. Right now, the Asia-Pacific region is way out in front, grabbing 40% of the market. A huge piece of that is China's absolutely massive EV market, which just creates this incredible appetite for all these advanced electronics.
Okay, so let's break this all down. We're going to look at what these little brains actually are, how they all talk to each other, what's behind this incredible market growth, and of course, what's coming next down the road.
So first up, let's get right to the heart of this network, the ECUs, or electronic control units. These are really the individual brains of the whole operation.
The best way to think of an ECU is as a tiny, specialized computer. Each one is an expert in its own little field. You've got one for the engine, another for the brakes, one for your touchscreen. You get the idea. Each one has one job to do, and it does it really well.
And boy, do they add up. It's not uncommon for a modern car to have over 70 of these things. Yeah, 70. That's like a committee of 70 different specialists, all needing to agree instantly for your car to just work.
So, right, if you have over 70 brains all in one car, how on earth do you keep them from all shouting over each other? How do you avoid a total information traffic jam and just, chaos?
Well, before the 1980s, it kind of was chaos. Cars used this unbelievably complex web of direct wiring. We're talking dedicated wires for every single function. It was heavy, it was crazy expensive, and honestly, it was a reliability nightmare. Something had to change.
And this was the change. Meet the CAN bus. Developed by Bosch, it's basically the vehicle's central nervous system. It's this super elegant and tough system that lets all those different ECUs communicate over one simple two-wire network. No massive central computer needed.
And you can see its journey here. It's been remarkable. It started as this clever idea back in '86, became a global standard, and it's been getting faster and more powerful ever since, with new versions like CAN FD and now CAN XL, just to keep up with the demands of modern cars.
But here's the really cool part. What's the secret sauce? How does the CAN bus solve that problem of multiple ECUs trying to talk at the exact same time without their messages crashing into each other?
The magic is in a process called bitwise arbitration, and it all comes down to this one simple rule. The network has two states, dominant, which is a 0, and recessive, which is a 1. And the dominant bit, the 0, always wins. It basically shouts louder than the recessive bit.
So here's how it plays out. Let's say a couple of ECUs start talking at once. They start by sending their messages priority ID, and the lower the number, the higher the priority. As they're sending, they're also listening. The second an ECU sends out a 1 but hears a 0 on the line, it knows it lost the argument. It immediately goes quiet and just waits for the line to be free. It's this brilliant self-policing system that guarantees critical messages, like from your brakes, always get through first. No collisions, no delays. So all this amazing tech is happening under the hood. How does it all connect back to that $120 billion market we talked about? What's really fueling this incredible boom?
It really comes down to a perfect storm of a few key trends. You've got the huge consumer demand for advanced driver assistance systems, or ADAS. Then there's the massive global shift to EVs and hybrids. And finally, governments around the world are mandating more safety features and stricter emissions rules.
And just look at the ADAS market alone. All those features we're starting to expect, adaptive cruise control, automatic braking, they all need their own specialized ECUs. The market for just those systems is on track to more than double by 2032. That's some serious growth.
And what's really wild is that this is happening even with major roadblocks, like the global semiconductor shortages that have been a huge headache for the entire auto industry. The demand is just that powerful.
So, here's the bottom line. As our cars get smarter, safer, and more connected, the amount of data they need to handle is just exploding. And it's pushing even the newest, fastest versions of the CAN bus right to its limits. I mean, just think about it. The sheer flood of data from high-res cameras, from radar,
from these giant infotainment screens, it's all incredibly bandwidth hungry. And that's setting the stage for a new competition, as a familiar name from the computer world starts to make its way into our cars. And here it is, the main event, CAN bus versus Automotive Ethernet. You can see the difference right away. Ethernet is an absolute speed demon, offering massive data rates and much better built-in security. But the CAN bus still holds its own with its rock-solid, real-time performance and that simple two-wire setup.
So that leaves us with this final, really fascinating question. As our cars basically transform into data centers on wheels, which network is going to win? Will the incredibly reliable and proven CAN bus keep evolving to meet the insane demand, or is the high-speed world of Ethernet about to take over the driver's seat for good? The race is definitely on.